Hello everybody, today we have to do the lab refraction of light. You know the refraction of light, when the light is traveling from one medium to another medium, it bends. For example, if you have let's say this is water, and let us suppose this is your incident ray. This is here medium 1, and here you can draw the normal n o n prime. This is your normal, and I o, this is your incident ray. This is your incident ray. And what happened is this point, this is point of incident. At this point, look here, this is water. Okay. When the light enter here, the light bend because the velocity change. So what happened is, it is supposed to go in a straight line like this, but it doesn't. It bends here like this. So this OR, this is your refracted ray. Okay. So now, this angle, you can call theta 1, this is your angle of incidence, angle made by the incident ray with the normal, and this angle, this one, okay, this angle is, you can call theta 2, this is your angle of refraction. Angle of refraction, this is angle of refraction, theta 2, this is your angle of incidence. Angle of incidence. And what we need to do here is we have to apply the the Snell's law. Snell's law, and Snell's law is n1 sine theta 1. This is equal to n2 sine theta 2. Okay, n1 is the index of refraction of air. N1, index of refraction of air, and N2 here is index of refraction of water. Okay, so index of refraction of air, we can write down 1 sine theta 1. This is equal to, let me write down N2 is equal to N. N is the index of refraction of water, N. I want to replace N2 by N, sine theta 2. So from here, look, what is N then? What is index of refraction of water? Okay, so this is sine theta 1 divided by sine theta 2. This gives you the index of refraction of water, this formula. So how do you measure the index of refraction of water? Okay, so you have to measure the angle of incidence, you have to measure the angle of refraction. That's it. And then you plug in this equation, sine theta 1 divided by sine theta 2. This is sine theta 2. Theta 1 is angle of incidence, theta 2 is angle of refraction. Then you get the index of refraction of water. In this case, N, this is, if it is water, N water is, we are supposed to get 1.33. Okay, but we do not measure the index of refraction of water. We want to use another transparent medium. Our another transparent medium is this. This is a glass slab. This is also the transparent medium, and we want to measure the index of refraction of this glass. So what you have to do is, take one cork board like this. I already did it here. This is a cork board. Okay, cork board. So put the cork board on the table, and then take your glass slab. This is a glass slab, And look, you keep the glass slab here, like horizontally, okay, like this. And draw the outline, okay? The outline is like a rectangle, okay? So it is like this. On the cork board, you have a paper. On the paper, you keep the glass slab and you draw the outline like this. This is your glass slab. This is your glass slab, okay? And somewhere here, using the protractor, okay, using this protractor right here, draw the perpendicular line like this. So this is my normal. You draw the normal like this, okay? And then our formula is, what is our formula? The index of refraction n equal to, in this case, index of refraction of glass is sine theta 1 divided by sine theta 2. Sine theta 2. This is the formula. So sine theta 1 is angle of incidence, theta 2 is angle of refraction. Okay. So here, make an angle of incidence 10 degrees. Start from 10 degree right here, make a 10 degree. So let us consider this is incident ray, and this angle is, you make 10 degree. Okay. So again, look here, you have a cork board, you draw the outline and you make an angle 10 degree, their angle of incidence, and again you keep the glass slab there, and right here and there you put two, like this, two pin. You have a pin, look here, two pin, okay, needle, like a needle. So one pin here and another pin there. They have to be in a straight line and perpendicular to the surface there, okay? So you keep the pin something like I'm doing here. Like this here, look. You have a two pin. You see 1, 2, they are perpendicular to the plane, okay? And you have to keep the glass slab right here, like this. You keep the glass slab right here. And look from other side. Look, this side there is a pin. Now look from here, this side. And put two more pin, keeping this glass slab here, put two more pin here and there. They must be a straight line. You look from the through the glass. Look through the glass. Refraction takes place there. So one pin, third pin here, fourth pin there. So what happens is, you keep the glass slab here and you look from this side, right from here. So because this whole thing is glass slab. So what happens is, you keep one pin somewhere there, here, another pin somewhere there. Okay, if you look from this side, all four pins, they must be line up, straight line. And first, join this line and this point and this point. First, join these 2 points, not a line. Join these 2 points and draw the line. This is the line. Okay, and join, this is the point of incidence, and join this. So this angle. So this angle is theta 2. Of course, theta 1 is, if theta 1 is 10 degree, theta 2 is less than 10 degree. Okay, less than 10 degree. In my case, I get 6.6 degree this angle. This angle is, theta 2 here is, theta 1 is 10 degree, my theta 2 is 6.6 degree. Now what happens is, I have to calculate the n. N is sine 10 degree divided by sine 6.6 degree. Now if you calculate this using the calculator, whatever number you get, and it is a glass, so you are supposed to get, I think, 1.5. I don't know, I do not have a calculator here, but please check this, okay? Check this. So this is the one case. Now you make angle of incidence 10 degree. Now next, draw another one. And this angle is 20 degree. And look from this side. Here, keep the glass there, and you put two pin here and maybe somewhere there. Join this, and join this point and this point. So this angle is theta 2 again, but this is, in my case, I get 13.3 degree. Theta 2 is 13.3 degree. So every time I have a 6th trial, I start from 10 degree, 20, and then I go 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, and 60 degree. My manual says go up to 70 degree, but ignore the very last one, 70 degree. Okay, I couldn't do that. Okay, so you have 10, 20, 30, 40, 50, 60, 6 trials. Calculate the index of refraction for each trial. Each trial must give you the 1.5 because the index of refraction of glass is 1.5. Okay, so here I already did the experiment. I can show you quickly. Okay, just hold on. Look here, this is the lab. So what I did is, first I take this glass slab. This is a glass slab. Okay, you see, this is a glass slab. I have to measure the index of refraction of this glass slab, rectangular glass slab. And I take a cork board. This is a cork board. Okay, you can see this is a cork board. And on the cork board, I place the piece of paper, sheet of paper. Then I use a pin, like this. You can see here to post the paper. And then here in the middle, I take a glass slab and keep there. And using my pen, I drew the outline. I drew like this. Okay, I drew the outline so that I can get, you see, the rectangle. That is the outline of this glass slab. And then I draw the, look here, you can see 10 degree, the first line, this line 10 degree, the second one is 20 degree, the third one is 30 degree, and the fourth one is 40, 50, 60. Please ignore this one. You don't have to worry about this. I didn't do this. Okay, and what I have to do is, I keep the glass slab right here. Okay, you see. And then I take two pin. One pin I put here, and another pin I put there. They are line up. Okay, they must be line up. You can see two pins there. And then I have to look from this side, right from here. Right from here. Look. From here, not there, not here. You have to look from here because the light coming from two pins, they are in a straight line. That light must pass through the glass slab. So I take two more pin and then I look from here. I cannot show you the video. I look from here and I put two pin, one here, this pin, and this pin, they are lined up. If you look through the glass slab, not from the air. And then second pin I put here. I put the second pin right there. And this is also lined up. All four pins, if you look from the glass slab, they line up. They must line up, and in my case also they line up. Okay, then this is done. Now what I have to do, I just remove the glass slab. Okay, and I remove this pin, and then you can mark the point here. And I also remove these two pins, and then I remove the mark here and remove the mark there. So 1, 2, 3, 4. 1 means first pin, 2 means second pin, okay. 3 means third pin, and 4 means fourth pin. And then look, I join the point 3 and point 4, this line. I join this line and this point here. I join this point and point of incidence so that I can get this angle theta 1. I write down theta 1 here. Actually it is theta 2. It is the medium in the it is in the glass. Okay, so this angle is 6.6 degree. I have a table here. For angle of incidence 10 degree, my angle of refraction is 6.6. For angle of incidence 20 degree, my angle of refraction is 13.3, and similarly you can see this table. Okay, so go up to angle of incidence 60 degree. Okay, and then using this angle of incidence and angle of refraction, please calculate the index of refraction of glass, and you must get 1.5. So you have a 6 index of refraction, but they must be the same. So if you average them, you must get 1.5. Okay, so this is all. So please do the calculation carefully. Your part is you have to make a calculation carefully. Thank you.